Hello everyone, this is the UBC Global Surgery Group, and here is our submission for the Innovation Competition 2024. This is a cricothyroidotomy prototype model. So first off, here is the list of material that we're going to use. We're going to use an empty water bottle in order to form the trachea. Some of the grooves will be used as the anatomical landmark for the tracheal rings. If they don't come with it, then we can use a metal wire that can be wrapped around the trachea in order to form that landmark. Scotch tape will be used to stitch everything together. Next up, we'll use an empty egg carton box in order to form the hyoid bone and thyroid cartilage for our anatomical landmarks. And for our membrane, we'll use a nitrile glove that can be found in most medical facilities. We can talk about electrical tape, which is an alternative later in the video. Finally, we have also an optional layer that we can add, which is skin and subcutaneous tissue. This will be composed of slime. Essentially, we need glue, laundry detergent, baking soda, and cornstarch in order to form that. So now onto building our model. We will take our water bottle first, as well as a sharp object, such as a scalpel, to cut out the top and bottom part of it. Afterwards, we'll cut what we have left in half and roll it onto itself and secure it with Scotch tape in order to form our trachea. Of course, we want our Scotch tape to hold very well, so we'll take a paper towel and simply dry out all of the remaining water that's left. And after doing that, we'll take our sharp object again to cut a square on the superior and anterior part of our model in order to make the window for our procedure. That way, it will also mark the first tracheal ring, as in the inferior edge of the square hole that we'll make will be that consist of that anatomical landmark. And of course, we have our tracheal rings more inferiorly that are made out of the grooves of the water bottle. Okay, once that's done, we will now use the empty egg carton box and cut out one little container in order to make our thyroid cartilage as well as our hyoid bone. We'll just trim out the excess cardboard and take any piece of cardboard that is either a bit curvilinear or more transverse or straight with a bit of glue in order to make the hyoid bone for our anatomical landmark. After that is done, we'll take our scalpel again in order to cut out the bottom part of the little container so that we can put the trachea inside and form our airway. Of course, we'll have to place our membrane before doing that. So we'll use our nitrile glove, inflate it, and simply glide the trachea or tube into one of the fingers. The advantage of doing that is that the membrane is reusable, so we can use the other fingers or even both sides of the glove in order to form the membrane. We'll secure it in place by simply tucking whatever is in excess of the tube superiorly and inferiorly. And now, as you see, we are plugging the trachea inside the egg carton. Now, we use the egg carton, the cover of the egg carton as a base to secure the trachea so that it doesn't move while we do the procedure. And we simply tied it down using one of the metal strings. Now we'll take our slime to form the skin and subcutaneous tissue, and as you see, it's very stretchable. And the advantage of using this is that it kind of really mimics skin. We're able to palpate the hyoid bone, our thyroid notch, our thyroid cartilage, and also our first tracheal ring and our cricothyroid membrane. And now that, as you see, we're just putting the outline of those anatomical landmarks, and finally where we're going to do our incision, which is at the cricothyroid membrane. We are making our incision, our vertical incision for our procedure, and just making sure that we see underneath, we see a bit of purple, which is our membrane. Perfect. We now make the transition incision. We confirm digital entry in the airway, and now we take our tracheostomy tube and simply put it inside. Now, the advantage of this model is that it's also easy to disassemble, so we can simply lift up the subcutaneous tissue and also lift up the glove to see that we are indeed inside the airway. So now this is our way of making slime. We'll use a bit of cornstarch to make the slime a bit more elastic and firm. Then we'll have a bit of sodium bicarbonate dissolved in a few drops of water. This will help activate the glue. And the glue itself, we will use about 8 spoons in our case. And we want about a ratio of 4:1 to the laundry detergent, so about 2 spoons of laundry detergents. And as you see, we're going to mix everything together to form the slime. Of course, there are alternatives for these ingredients, but we have elected to use these ones as we found that they would be most accessible and affordable for everyone. Alternatives for an activator of the glue, so a replacement for the laundry detergent and sodium bicarbonate, would be to use borax or contact lens solution. And as you see, we keep kind of mixing everything together and adding a bit of cornstarch to make it, again, more elastic. And eventually this will become more solid and more elastic than what we have right now. The reason why we chose to use slime particularly for subcutaneous tissue is that it mimics human skin pretty well. Also, it is reusable, so even if we cut through it, we can just remodel it to form the shape that we want again. An alternative to the water bottle would be to use any already pre-made tube-like material, such as a plastic or a rubber hose or tubing, or even a ventilator or a tracheal mask tube. The only issue that we had with those materials is that they may not be readily accessible, as they may be a bit more expensive. Alternatives for membranes include a rubber band or elastic. However, although it is accessible and affordable, it is very difficult to cut and to put our endotracheal tube or tracheostomy tube without breaking it. Secondly, there's also electric tape that we found was a pretty good alternative, as it's pretty solid, robust, and can be cut through. However, it is a bit hard to find, so accessibility was an issue. An alternative to slime would be to use Play-Doh for skin and subcutaneous tissue. Although it molds very well into the shape that we want, it's not as elastic, so when we cut through it, it's not the same consistency or similar consistency as human tissue. Our second issue was that it would not be accessible everywhere. And thirdly, because of the fact that it's not as elastic, we had some difficulty palpating the model's anatomical landmarks. This project could not have been successful without the collaboration of our team, comprised of 2 surgical residents, 2 biomedical engineers, and 3 medical students. Thank you for watching.